The following video will walk you through the new local search dining app we designed to better inform customers about the sanitation conditions and food safety issues of the restaurants they choose. Behind this app, we use the food inspection results released by Chicago Department of Public Health and other related data to build a prediction model to forecast each restaurant's probability of failure in the upcoming inspection. Our prediction results are combined with the user's reviews into an evolving information system, which can better serve the public to reduce food poisoning risks in the future. Have you ever been poisoned by food? Our friend Peter got sick after dining in a restaurant with a high score on Yelp. He posted a complaint and gave it the lowest rate, but his complaint got buried among all the compliments. Today, we are already used to make our dining decisions based on the rating and review system. However, for most of the time, we only talk about the taste, the price, or the service. But what about the safety of the food? About 3,000 people in the U.S. die every year from foodborne illness. Although health departments are doing this food inspection regularly, most of the data are just posted deep within the government's website. And what Yelp is trying to do now is just enable local government to display their inspection data as a business attribute on Yelp. But the data is all about the past. What about the future? So we believe that the public needs more and better ways to digest the data and be engaged in the process of inspection to prevent foodborne illness from happening again. And moreover, with such an emphasis on the safety of food, we can also promote the concept of healthy eating through this platform. Okay, now let's see how our app works. When you enter the app, you can see your location on the map as well as the surrounding restaurants. Each restaurant has a score attached to it, which is calculated based on its inspection result history, the customer reviews, and our model predictions. Once you tap on a dining spot, the map can direct you to the place you choose. By swiping left, you can also see other options. Tap on the bubble to view more detailed information about the restaurant, including its performance in recent food inspections. If you are a determined healthy eater, on the recommend page, you can view the places that are rated as the healthiest ones. You will also see a list of restaurants that are making progress regarding their food safety conditions, which is reflected by both recent inspection results and customer reviews. You can also view more detail about each restaurant by going into their individual pages. On the history page, you can post your review and choose to copy it to the inspector or the business owner. If you post a complaint, other users will also be able to see it, and if they have similar experience, they can choose to endorse your review. Below that, you can also take a look at your dining report and be reminded to take care of yourself if you've been a high-risk eater recently. So here is our modeling process. In the original dataset from Chicago's Open Data Portal, there are many types of results. After we clean the data and filter out only the results as pass, fail, and pass with conditions, we count pass with conditions as fail because we want our model to capture as many violations as possible. As we know, food storage and processing issues are associated with season and temperature. Now let's look at if there is a relationship between inspection results and inspection date, or the temperature of that day. From the plot, we can see that the number of failures drops in winter and increases in summer each year, and as the maximum daily temperatures goes up, the number of failures on that day tends to increase too. With the daily temperatures as one predictor, our model can predict the probability of failure on each day with more accuracy. Here are our model results. If we train our model on the inspection data of 2015 and test it on 2016, the results show that our model performs well, as the accuracy of prediction for both datasets are around 0.8. Two major limitations of our models include that, firstly, our model is biased due to the presence of one extremely strong predictor. Secondly, we lack the data of many important features which may be related to inspection results. For the app, we will go on to find a better way to validate the complaints posted by customers and make them more legible and noticeable in the app, and to improve the user interface for restaurant customers to communicate with local inspectors and restaurant owners.